So here we have a situation where a dragon launches a fireball and it lands 94 meters away and it happens in 5 seconds. So what we need to figure out is what is the initial velocity with which the dragon launched the fireball and also at what angle. So we're looking for this angle right here, our theta. I also want to know what is the final velocity and at what angle does it hit the ground. Alright, so we have the final velocity vector, and I want to know at what angle to 0 does it hit the ground. Right here. Alright, and then also how high does it go? So first we need to figure out what we have. We know that the time is 5 seconds. And we know that our displacement in the x direction is 94 meters. We also know what acceleration is because in the x direction our velocity is always constant, which makes our acceleration 0 meters per second squared. And in the y direction, our acceleration on this planet is negative 9.8 meters per second squared. For right now, we know that it's a ground-to-ground situation, so our displacement in the y direction is 0 meters. And then we need to solve for the initial velocity, so we can solve for our initial velocity of the fireball. So we know that displacement over time is velocity. In the x direction, since our acceleration is 0 and our velocity is constant, we have the luxury of using displacement, well, velocity is displacement over time. Okay, so 94 divided by 5 seconds. And we get 18.8 meters per second. So 18.8 meters per second is our initial velocity as well as our final velocity in the x direction. In the y direction, if we could just figure out what the initial velocity that it went up with, we know that the final velocity will be the same thing, just down, so it would be the same number, just negative. So we can use the formula without final velocity, which is delta y equals initial velocity times time plus 1/2 at squared. And we know that the displacement is 0. We're trying to solve for the initial velocity. Our time is 5 seconds plus half of negative 9.8 is negative 4.9 times time squared. So 5 squared is 25. So we can rewrite this to say, let's see, we can multiply the negative 4.9 and the 25 out. And get negative 122.5. So 0 equals our initial velocity times 5 minus 122.5. So now we can actually add 122.5 to both sides. On the right side, it would cancel out, and that would equal initial velocity times 5, and we could divide both sides by 5 to find our initial velocity. Over here, it cancels out, and we take 122.5 and divide by 5. And we have an initial velocity of 24.5 meters per second. Now, if our initial velocity is 24.5 meters per second, our final velocity will be negative 24.5 meters per second. So now we have a situation where, I'm going to switch my colors really quick. We have this velocity right here. I want it a little darker. And we know that the velocity in the x direction is 18.8 and the velocity in the y direction is 24.5. 18.8 and 24.5. So the way that we would find our final velocity, this vector here, is we use the Pythagorean theorem. So a squared plus b squared equals c squared. So 24.5 squared plus 18.8 squared. And then I like to store that value as x and take the square root of x. And we get 30.9. So this is now 30.9 meters per second. And at what angle? Well, when we want theta and we know our sides, we use the inverse of a trigonomic function. When we have our opposite and adjacent side, we'll use the inverse of tangent. Inverse tangent of y over x, where our y was 24.5 and our x was 18.8. So inverse tangent of 24.5 over 18.8. And we get, I'm getting a really small number, and that doesn't seem right to me. So I know that I need to go and check my mode, make sure I'm in degree mode, which I wasn't. So I need to redo this, 24.5 over 18.8, and I get 52.5 degrees. Alright. The final velocity would be a final velocity vector. Since the x component is constant, this would be 18.8, while this would be negative 24.5. So whenever I use the Pythagorean theorem, it will actually be the same value, 30.9 meters per second, but our new angle will be the inverse tangent of negative 24.5 over 18.8. Okay, which is opposite, so our theta here is negative 52.5 degrees from 0, or 360. Alright, now we want to know how high did it go. So we need to change some variables here. The initial velocity is the same, but now our final velocity is 0 meters per second. At maximum height, it is not moving at all. Our acceleration due to gravity is the same, but this time we don't know how high it went. And then also, what we need to do with our time, since we're talking about how high it went, we need to chop our time in half. So we're actually talking about a time of 2.5 seconds. 2.5 seconds. And we want to know how high does it go. So we can go ahead and use this same kinematic equation. So how high it went would be delta y equals our initial velocity, which is 24.5, times time, which is 2.5 now, because we halved it, plus half of our acceleration, which is negative 9.8, times squared, so 2.5 squared. Alright, so we could say 24.5 times 2.5, we get 61.25, and then we're going to subtract, or I guess we could add, and then 0.5 times negative 9.8 times 2.5 squared. And we get 30.6. So it went a height of 30.6 meters. And we're done.